for this segment, I'm going to review with you and probably provide a couple of written examples of how to pick the correct t-value from the t-probability distribution when conducting a t-test for two independent samples. In addition to picking or choosing the correct t-value, I'm also going to provide some examples of how to set up the probability distribution in order to conduct the right drawing to solve your problem. If you have your t-probability distribution handy, you might want to have that out while we're going over this segment. So if you have your SPATS book, you can find that on page 388, just like before. And there's also copies of it available in a couple different folders on Blackboard. So hopefully you can find and gain access to the t probability distribution fairly easily. All right, here's what I want you to assume. Okay? I want you to assume a two-tailed test at the 0.05 level. N sub 1 equals 10, N sub 2 equals 10. Okay? If I seem distracted, it's in part because I think my dog is getting in trouble. Roxy. Roxy. She's a little shy. All right, so this is the information. Come here. This is the information that I asked you. Come here. Come here. You want to say hello? Come here. This is Roxy. She's at home. She's feeling lonely and bored. Roxy, the stats dog. Say hello. No? All right. Stay out of that room, please. Okay? All right. This is the information that I want you to keep in mind. Okay? A two-tailed test at the 0.05 level, that's alpha, right? That symbol right there is alpha. Two-tailed test at the 0.05 level, N sub 1 equals 10, and N sub 2 equals 10. So 10 cases in sample 1, 10 cases in sample 2. Also, two-tailed test, how do you know if you need a two-tailed test or a one-tailed test? Well, guess what? It's dictated by your hypotheses. So your reading of the hypothesis will indicate whether you need a one-tailed test or a two-tailed test. I went over that in some detail in a previous week's material. It's labeled accordingly. So if you need a refresher on that, please consult that, because the dynamic with a t-test for two samples is still the same. If the hypotheses indicate direction, you need a one-tailed test. If the hypotheses do not indicate direction, you need a two-tailed test, right? And what do we mean by direction? Well, if the hypotheses are specifying direction, that means that words are contained in the hypothesis that are indicating that one group is going to be faster or slower or bigger or smaller or heavier or lighter or whatever. Any type of direction indicates you need a one-tailed test. In addition, the direction that's stated, sometimes you have to think about that, but the direction that's stated indicates, or it will indicate, the direction that's stated will indicate whether your rejection region, the tail, the critical region, should be in the right side of the distribution or the left side of the distribution. All right, so keep that in mind as well. Same thing holds true for t-tests for two samples. If there's direction specified, you need a one-tailed test. If direction is not specified, you need a two-tailed test. So when direction is not specified, it will simply say that the two groups are different, or that the two groups are the same. Saying that two things are different without a preconceived notion, or saying that two things are the same, You're not indicating direction in that regard. So back to the task at hand. Two-tailed test at the 0.05 level, n sub 1 equals 10, n sub 2 equals 10. Well, degrees of freedom, I know you can probably do this in your head, but I'm going to do it right here with you. Degrees of freedom equals n1 plus n2 minus 2, which equals 10, plus 10 minus 2, which equals 18. So we've got a two-tailed test at the 0.05 level. Degrees of freedom are 18. So let's consult the t-table. You do the same with your copy, and we will go from there. Two-tailed test, 0.05 level, 18 degrees of freedom. If you chose a t-value of 2.101, you are correct, right? 2.101. Now, another similarity with the t-test for two samples is that number represents, this is very important, the amount of standard error you could expect to surround the difference between two means given the information that you know. Up to that amount. That is the amount, or more specifically, that is up to the amount that you could reasonably expect to surround a mean's difference given the conditions that you're working with. And what are those conditions? A two-tailed test at the 0.05 level, you've seen this before, a two-tailed test at the 0.05 level with 18 degrees of freedom. So, and we just determined, I believe, that the 2.101 is the t-value. T equals 2.101. Okay, well, let's see what this would look like if we were setting this up in order to draw the probability distribution. You're going to find, I hope, it is my hope that you will find, that there aren't a whole lot of differences between setting things up. So degrees of freedom equal 18, alpha level equals 0.05, two-tailed test. Okay? I haven't put the t-values in, but I will. I just simply put my legend up here. Degrees of freedom equal 18, alpha level of 0.05, two-tailed test. 0.05, two-tailed test means that area, 0.05, is split evenly between these two tails, 0.025 and 0.025, or together, 0.05 plus 0.95 equals 1. 0.025 plus 0.95 plus 0.025 equals 1. The whole thing equals 1. Now, I'm going to simply put in the correct t-values. T equals negative 2.101 on the left. T equals positive 2.101 on the right. And in order to be absolutely complete, I'm going to put a t-value of 0 in the middle. That's how that would that is how that would end up set up. All right, I'm going to go through another example after an example of setting up the probability distribution in another segment after this one.